Isn't it amazing how a relatively easy, maybe even common sense type of calculation involved so many of the different skills that we've been trying to develop with you this year? Now, the world isn't made up of only rectangles. There are also other shapes. Sometimes we might need to calculate the area of a triangle or a circle. Let's have a look at how we might calculate the area of a triangle. As before, I could start by simply putting down my triangle and then taking a piece of grid paper and placing that over the triangle. What I could do now is to count the number of squares needed to cover the triangle. And once again, I'd have the problem of what to do with those part squares along the edge. As I said earlier, it simply isn't practical for us to spend our lives walking around with a piece of grid paper in case we want to determine the area of a shape. For that reason, we want to develop a formula. Now, because we're inherently lazy, we ask ourselves the question: we've already determined a formula for calculating the area of a rectangle. Is there any possibility that we could use that same formula for calculating the area of a triangle? And the answer is we can. What I'm going to do is I'm going to take the red triangle, whose area I want, and I'm going to cover that with an identical yellow triangle. And I'm going to put both of them down on my piece of paper like this. What I have here is two triangles with exactly the same area. Now, I'm going to use my ruler and I'm going to draw a line from this corner of the triangle, this vertex, and I'm going to draw that at right angles to the opposite side. We would call this a perpendicular line. It is at right angles. Now, what I do next is I'm going to take a pair of scissors and I'm going to pick up this triangle and I'm going to cut it along that line. And let me put it back where it came from. Now, I'm going to take this triangle here, or this part of the yellow triangle, I'm going to turn it around and I'm going to put it down against my original red triangle like that. And I'm going to repeat that on this side over here. And what I want you to notice is that I've created a rectangle. And what's special about this rectangle is that it's made up of the red triangle, whose area I'm interested in, and the yellow triangle cut into two pieces. In other words, the area of this rectangle is 2 times the area of the red triangle. If I now call this here the length of the rectangle, and that's the breadth of the rectangle, then I've got a formula for calculating the area of that rectangle. And I know that the area of the rectangle is equal to length times breadth. But remember, I'm interested in the area of the triangle. Now, the area of the triangle is exactly 1/2 of the area of that rectangle. Why? Because the area of the rectangle is effectively 2 times the area of the triangle whose area we're interested in. So we could say length times breadth divided by 2. Now, in fairness, I need to modify this formula ever so slightly. Where did this value, the length, come from? If we look carefully, you'll see that the length, that side of the rectangle, is the height of the red rectangle. That is, the length of our rectangle is this height over here, which I drew in and cut out. Notice how you can still see the mark of that on the ends of the rectangle. We call this the height of the triangle. So the formula for a triangle really needs to be modified to the area of the triangle is equal to the height times the base divided by 2. Did you know that? I love doing that demonstration.